All right, we're now into week 3. We've started talking about equilibrium, and we have several types of problems to talk about this week. So the first type of problem we're going to deal with is the reaction quotient. So the only difference between the reaction quotient and the equilibrium constant is that the reaction quotient uses initial concentrations, whereas the equilibrium constant uses equilibrium concentrations. And so, if we calculate the value of Q and compare that to the value of K, we can decide which way a reaction will shift to achieve equilibrium. So let's pretend that I give you this problem. I'm giving you the value of the equilibrium constant. Now remember, you can write it as K or KEQ or K sub C. They're all the same thing. So if I tell you that I have a 750 milliliter solution, 750 milliliters, and I dump 1 gram of acetic acid, 1 gram of H plus, and 1.3 grams of acetate into it, which way will it shift to achieve equilibrium? That's what I want to find out. So the way we're going to figure out if the system is at equilibrium is to calculate Q and then compare that to my value of K that I was given. And then when you compare Q to K, you can see which way the system will shift. Okay, now the problem gave me grams, right? I cannot plug grams into an equilibrium expression. It has to be in molarity. So the first thing I need to do is I need to convert grams to moles and then divide by the volume of the container. Remember that this little 0 means initial. So the initial concentration of acetic acid, 1 gram, the molar mass is 60. So that's 0.0167 moles divided by the volume of 0.75 liters. So the initial concentration of acetic acid is 0.0222. You can just carry out extra decimal places in these molarities because you're going to do all your rounding at the end anyway. The initial concentration of H plus and the initial concentration of acetate. We're doing the exact same thing to get these molarities. And now we're going to calculate Q and compare that to K. Now K was given. K is 1.8 times 10 to the negative fifth. So these are my same values that I just calculated on the previous slide. And so how do I get Q? I just write my equilibrium expression, and instead of inserting equilibrium concentrations, I'm going to insert initial concentrations. So the initial concentration of H plus, the initial concentration of acetate, the initial concentration of acetic acid. So 0.0294 times 2 divided by 0.0222. So that comes out to be 2.64. Now, from the notes, you will remember, if Q is greater than K, the system shifts towards the reactants. It shifts left. If Q is less than K, it shifts to the right, and if Q equals K, it's at equilibrium. So here, Q is much greater than K, right? So that means that I don't have enough reactants. For this to reach equilibrium, I need a lot more reactant to form. So the equilibrium will shift towards the reactants. In other words, more acetic acid will form, and that will get me to equilibrium.